What's up, you guys? JP here. So we're back on the 77 Toyota Celica Franken Yoda project. We're back to working on the cantilever rear suspension we're designing. We'll take you inside of this and show you what we're doing. So we got the two shock towers we're going to design. We kind of drew them up in one of the older videos, just like a quick little draw up. But we got them drawn up in CAD. We're going to see if our design works. We have some QA1 dual adjustables. These are 9-inch springs, 350 pounds, and they are 14-inch fully extended, 10-inch not extended, compressed I should say. So we're going to head on into the shop and we're going to go ahead and get our test piece cut out from a piece of scrap metal we have. We're going to just use a piece of scrap metal to test to see if all our angles are going to work. So we got that set up here. We'll do a quick little video demo of what we drew up on CAD, but let's get this cut out and then we'll go test fit it. And if that works, then we'll go ahead and cut out our cantilevers, or AKA bell cranks that we have. We designed those and we got the mini lathe. We're going to be able to use a mini lathe on a few of those parts, plus the TIG welder and the plasma cutter. So let's put all this equipment to use. Stay tuned. All right, so we got the little test piece loaded up here. Again, scrap. I think this is a little over 1/8 inch. Obviously, we're not going to do anything structural with that. But we are going to cut it out just to test to make sure it's fitting properly in between the shock towers. They actually have a slight taper. They go from 29.25 inch to 29.5 inch over about a 4.5 inch difference. So it's hard to tell on the drawing, but this actually goes out. So hopefully this will pick it up. Hopefully it'll fit right in, but let's go ahead and get this thing cutting. All right, waiting for the compressor to kick off so we can actually hear ourselves think. Okay, here is our concept. Now we'll see if it'll actually fit in the car itself. Again, this is, you can see how it tapers up ever so slightly, about a 1/4 inch from here to about there. We're gonna go see if that actually lines up. All right, so if our measurements are correct, this should fit right there, in which it does, right at the edges of this. Now we do need to probably shave for this rear one. We're gonna have 2 of these plates, and that one will have to be shaved, just sanded just ever so. It tapers in just ever so slightly, so we'll have to shave the corner. But for this front side, which is our main one, that is gonna fit beautifully. And so what we're gonna have here is our bell crank cantilever will sit and pivot here, and our rod will come up through internally inside these 2 pieces, and then we'll reinforce these pieces across. Let's see if we can get this to sit. So we'll reinforce these pieces across, and we'll probably do some relief cuts on them as well, so that they're not just a solid piece of steel. Probably do a little design in here, cut out some of it. But this will be, if all goes well, this will go up to our cantilever, and then we'll have to see clearance wise how wide we need to go. But these will sit in here like so, if this concept will work. These are going to sit in about 1/2 inch each side, and then we'll have to see where these pivot. But for now, that's looking really good. Man, it's cold out here. So the bell cranks we designed are allows for a 4-inch shock travel for a 6-inch suspension travel. So we are changing the motion ratio, the rear of the car, only because we don't have a lot of room to work with. So we want to be able to have, room for compression and rebound, a good 6 inches of travel on the rear end, total travel. But we only have a 4-inch stroke shock. So the cantilevers we designed, or bell cranks we designed, are specifically and mathematically to allow the shock side or the suspension side to travel 6 inches, and the the shock to travel 4 inches. So here is the design. We showed you it in CAD a little bit, so we're gonna go ahead and get this machine ground, and we'll get this cut out. So this is the first half. Of the bell crank. So we've got a lot of dross. On our settings on our machine, we had to, it's supposed to have a 5mm lead in, but these are only 5mm wide, so we had to go, it won't cut them out, it won't recognize them in AutoCAD, so I'm not quite sure how to figure that out. So I found that if I do the lead in down to 2mm, it will detect them and cut them, but it leaves for quite a bit of cleanup, unfortunately. But this is one side, and then we're gonna go ahead and cut out the other side. These are our 2-piece cantilever, and I'm gonna grab this. So our pipe here, and we can machine this down just a little bit with the lathe so it fits perfectly. But our pipe here is going to go in there and sit flush. And then we're going to machine inside of here to press in some roller bearings, and this will be the pivot point of the cantilever with bearings. So let's cut out the other half, and then we'll go from there. All right, so once we get the dross cleaned up, these will sit like that, and now it's time to cut our little spacer. So between the spacer being welded in, the pipe being welded in, they'll sit in three-dimensional space like this. I'm gonna go ahead and cut that base plate. This is what that interlocking plate looks like. All right, once we get the holes kind of cleaned up, the dross cleaned out, these are going to interlock right inside. If you look at the actual step, it's the same thickness as the material. So these will go all the way through once they're cleaned up, and they'll come out flush with the other side, and then we can weld them. So it'll be really, really strong. That will sit like so. Then we need to cut the pipe to the right length. So let's get this all cleaned out first, and then we'll get the pipe set up. Okay, went ahead and we finished cutting out the other side. I did find that if I slow down my cut rate, I was doing the recommended cut rate for this thickness of material, but because these holes are so small, I slowed down the cut rate, and it seemed like the cuts got a little bit more precise, so a little less cleanup at least. So we got all of these cut out. So now we just gotta ream them all out, make sure everything's gonna fit. Give you guys an idea of what this is gonna do, or what it's gonna look like, I should say. So with that pipe in here and then the bearing has a 1/2 inch hole, so it'll be centered there. So this will be right on inside of this with the bearing. And if I can get that shock out again. Again, this is just a rough, we've never built a cantilever system, so we're just kind of learning as we go. And I get the concept behind it. It's fairly simple, but so this will sit here to here like so. And then as that turns, obviously it'll compress. So we just got to make sure everything clears. Once this is all together, we can do a dummy test fit. That's why I wanted to make this dummy plate, to make sure all of our clearances were going to work. Worst case scenario, we can make this wider than it needs to be on one side, and the shock could fit inside. So, but yeah, so that's going to be eventually hooked up to that. I got the shocks with the bearings. So these have bearings as well, so they'll be able to roll nicely. You don't want to put any torsional load on the shaft sideways, so we got to make sure our angles push down straight enough. We want to try to keep this at as close to a 90 as possible. So we're going to go ahead and get these things cleaned up, and then we'll bust out the sanding belt, knock off all this dross, and then probably take our little, we have a little carbide bit. We'll probably just clean up some of these holes, make sure everything's looking good. I don't think we're going to worry too much about the sphere, the circle here, I should say, only because we can machine that pipe down quite a bit. I want to say this is 3/16 wall. I mean, it's heavy duty, so it's tubing here, so we'll have more than enough material if we need to use the new mini lathe and machine it down so it just slides just perfectly in. And then also I'll grab the bearings and show you guys those. Here, here is our roller bearings. I'm gonna set you down and show you on the other camera here. Whatever. Okay. So these are almost within their tolerances to be pressed in. These are our bearings here. They do have a raised lip that will sit right, will catch right on the end of the pipe. Again, this will be flush with that. And we'll cut the pipe to length so it can go across, and then there'll be a bearing here and a bearing here. This will be about roughly just a rough 1.5 inches here. Because you got to do, we have 1 inch, a 1 inch gap. So we need 1 inch plus the thickness of the material, basically times 2. So that's 3/16. So it'll be pretty dang close to 1.5 inches. That will cut this down to for our pieces, and then we'll, like I said, we'll chuck them up in the lathe. We'll machine. We'll use the lathe for the first time and get those machined down. All right, we're gonna grab some safety glasses, grab all these parts to clean off. Grab our safety glasses here. Set these on the ground so they don't vibrate off. And okay, so one of the first things we want to do is we want to take our micrometer, and we're going to go ahead and measure this material thickness, and then we're going to add it to our 1 inch gap that we want to place. So let's take our micrometer. Set it to true 0. Lock it down. Okay. Our material thickness is 0.185. 0.185. So we're going to times this by 2, and then we're going to add 1 inch to that. All right, so our 0.185 times 2 is 0.37. We got our pipe here. We need to add 1 inch to that, so it's going to be 1 inch, 0.37. So I'm going to go over to 1 inch. Then we're going to go to 3. Here's 2. Here's 3. 0.7. Just going to use the micrometer to scribe a small line. Then we're going to take our Sharpie. We're going to mark our line so we can see it. And we want to cut on this side of the line. We'll go and toss this up in the chop saw and go from there. One thing I personally still need to get for this shop is a bandsaw. We don't have one. We just have our chop saw. We have a metal cutting blade on here. We also have a voltage reducer, basically, to slow down the blade, especially for this thicker stuff. So, actually, the device is set up on this side. So let's get it all lined up. All right, see where we're at. Should be tolerance-wise, we are at right there, 1.372. I don't even think I'm gonna even shave that down. We'll clean up the edge, but that's damn good right there. So we want to do the same thing to the next piece. Want to get 1.37. Make a little scribe. Okay. Got our scribe. Get our mark. Okay. Same thing here. Set this guy up. That one's a little bit higher. We're at almost 7.6. So we're gonna hit these on the sander real quick. We'll deburr them, and all right, just got those smoothed out real quick. We'll deburr the inside, even though we are gonna machine these, but bam. So we got our carbide bit in our die grinder, or wireless die grinder. We're gonna clean these up, get some of the dross out of there so our piece can fit in there, and then we'll get the pipe, the tube put up on the lathe and get that going as well. little bit of clearancing. Piece goes in there nicely. So we're going to clearance the other piece, and we'll do it to both sides. It's going to be the same exact thing, so I'm not going to bore you with all of that, but we're going to go ahead and get this side machined out. And we'll get that in there. And like I said, we'll once those are together, we'll machine out our pipe here so it can drop right in. Something I want to show you guys. So look how accurate this thing came out. So that is my glove centered. There you go. I mean, I don't know. That is like awesome. Same width. Alright, so we decided to get one done. We'll do the other one on our time. So this video isn't 4 hours long. But we have basically what we need. These will line up. We're not going to press them in like we did this side yet. But those will fit nice and snug once they're pressed with our hydraulic press. But I want to be able to drop this piece in first. Make sure that's all going to work prior to doing any of that. Make sure everything's centered. Just in case we need to shim it this way or that way. Because these are kind of hand cut, but they should be. They look dead on. So next what we're going to do is we haven't even used this lathe yet. It's brand new, so we're going to figure out how to use it properly, which bit we're going to need and stuff. So we're going to go ahead and take one of these, set the other one down with the other pieces, and let's get our chuck, if I can find it, probably in the toolkit. Yep. All right. So I believe there are other teeth, but this one should work for what we need to do. Make sure none of these are bound up. So what I did is I took this and I went all the way flush against the face here and then brought it back out. So it should be true, or as close to true as possible. So I'll go ahead and tighten up all the chucks. All right. Okay. Now we need to get a turning tool. Let me get all that organized real quick. So first things first, we want to take our micrometer again, make sure it's zeroed out. Working at 1.715. 1.715, and we are at 1.75. So take about 40 thousandths off. Again, this is just a first run. We're just going for it. So okay. That is an optical illusion. No, it's turned and centered. Okay. And we got some, let's see. All right, well, we got some major wobble, and I'm not sure, no, it's not in the chuck, so. It could be in the thickness of the wall around the pipe itself, but we're gonna go ahead and okay, let's check our measurement before we cut too much off. Micrometer, must have put it away. Make sure this is 0. Yeah, it's 0. Okay. So we have we've taken off almost 10 thousandths. Still got a ways to go, quite a ways to go. I normally be using cutting oil, but the brand new cutting oil I just bought froze last night. So it's, okay, so from 0.5 we're down to 0.35, 0.35 I should say. So we need to be at, for this to clear, here we go. Okay. About 5.005, so keep going. I don't know why sometimes this thing likes to slow down, so we'll have to figure out that. All right, we're at 2.5, so a few more cuts. We can take this thing out and test fit it. I'm just visually guessing that I'm far enough. I'm hoping I am. I can be a little past it. Yeah, good. Awesome. Because that's all going to get welded. So let's see how to surface the front of this bad boy right here. I don't know if that, yep. Guess that does. Okay, well, let's just give this a shot. Again, this is the very first time I'm using this lathe. It just got here last week, so Definitely needs some improvement, but all in all, it machined down what we needed it to machine down. And that, my friends, should press right in there. So actually, I don't even think we need it to press. I think we can just get to a flat surface and tap it in. Awesome. There you go. So should be able to get that down to where we need it to be flush. So next we need to machine the inside of this. Luckily we can put this flat against the chuck for that. And I think we need to find a boring, I think this is a boring rod, as they would call it. So we are at the inside diameter of this here. There's a little bit of tolerance. Okay, there we go. 1.37. 1.37, and our bearings are 1.375. Okay, I had to shim that boring tool, so let's see what we can do. Want to be at 0.72 because this is 0.75. We want it slightly 0.03 tighter, and we're at 0.72 now, and that feels like it's going to press right in. So we're going to call it good on that. Yep, there we are. Okay, now, you guys, check that out. We're going to go put this in the press. We're going to press this all into place. We're going to pass this, so we're going to press this across the surface. More up here. All right, there is one bell crank for our system. We're not going to press the bearings in quite yet because we want to get these things welded. We don't want to fry the bearing while we're welding, but this will go in here. And this will go in here, and they'll be pressed in. And this will be our rotating mass, suspension, shock. Let's go check it out in the car. So, again, our bell crank will be placed once the bearings are pressed in, everything's finished up. They will be sitting right here. All right. As they rotate, that should be our compression. Guys, that's it. So we got the bell cranks designed. We got to use our mini lathe. We got to use our plasma table. So awesome. We're gonna finish making the other side. It's the exact same process. On another video, we'll probably weld these things up and we'll come back to you guys and hopefully we'll pick up some steel. Right now, the little test dummy piece that we made in the car is, like I said, I think 1/8 inch. We're using 3/16 plate for everything. And then we're gusseting everything so it's got extra reinforcements. So anyways, thanks for watching, you guys. If you love this kind of content, please think about liking, subscribing, leave a comment. What else you might want to see. Thanks, we appreciate you. Till next time.